Okay, well, let me get started because I've got a lot to cover and not too much time. Looks like there's a little bit of a logistics issue with the room, but hopefully you get comfortable here. This is a topic on SharePoint infrastructure. My name is Michael Knoll. This is, I think, my 20th time to Australia. I do love it here. It's a beautiful place. I've been every place but the Northern Territory, and I plan on going there actually at the end of this week, so that'll cross the rest of the country off my list here. It's always, I always like the Australian crowds, actually. There are a lot of good questions come out of it. A lot of, you can tell a lot of people work with SharePoint, so there's a lot of real-world experience. And this particular session is actually about the best practices that have been learned with SharePoint infrastructure over the years. I worked for a company called Convergent Computing. It's based out of the San Francisco Bay Area, and we've been working building SharePoint environments for the past 11 years or so, since SharePoint 2001. So we've also were involved early on in the process with the beta versions of the software. In fact, we're actually starting to write the next version of our SharePoint Unleashed book. We actually completed the outline for SharePoint 15 Unleashed, but the most recent copy of what I've been working on that's released, it's called SharePoint 2010 Unleashed. And incidentally, if you after this session, Quest Software at their booth in the Expo Hall is going to be giving away 39 copies of these, so I'll be there to sign some. It's kind of a first come first served basis giveaway. But this particular session, this is what I call my drinking out of the fire hose session. There's a lot of information. It comes at you very quickly. I cover a lot of different topics. But what I did is, over the years, as I would run into something that would be a challenge to my customers, I would take note of it, and then I would include it in this particular session. I had this session for SharePoint 2007. It's, of course, changed quite a bit for SharePoint 2010 as the best practices have been formulating over the years. But I'll be talking about storage, things such as RBS. I'll be talking about security, a lot of different layers of security. I'll be talking about SharePoint virtualization, which has been a hot topic over the years. We've been doing a lot of virtualized SharePoint environments, so I'll give the best practices around those. The idea is that not necessarily you remember all of this, but that you can take a few key pieces of information and bring it back into your environment, especially if you're involved with designing a SharePoint environment. But even if you're not, we've had, if you're a developer that's interested in some of the back-end working of SharePoint and how you'd set it up, that's what you can get out of this session. One of the things I'll be demoing in regards to the virtualization side of things, I'll be demoing the creation of a SharePoint farm. So it'll take me about 15 minutes from beginning to end to create a brand new SharePoint environment from the OS creation all the way to the point where I run some PowerShell scripts and create a SharePoint farm. So that gives you an example of how you could actually quickly scale up a SharePoint environment. A couple weeks back, I actually got involved with the largest SharePoint design that we as a company got involved with, which was a 500,000 user SharePoint environment. So definitely looking at scalability in terms of how SharePoint can be designed, and I'll talk about the ways that we actually architected that environment here. Okay, so just starting things off. Oh, and one last thing to note is I'll be giving away, I guess, a free ticket to the SharePoint conference in Melbourne, which is next March. And I haven't quite decided yet how this gets, this is given away, but it'll probably have something to do with a question related to the content. So if you pay attention to the content, you may be lucky. Okay, when we're architecting a SharePoint environment, as an architect, the first thing you have to understand is that really SharePoint itself is a three-tiered application. You've got your web tier, you've got your data tier, and then there's a middle tier in SharePoint 2010 called the service application tier. You architect around these concepts. And the reason why you do that is because a web server has very different operating system requirements than a database server does. So oftentimes, if you end up putting those roles together on the same boxes, you'll get a lot of contention between these various types of roles. The web role is where the users connect into. It runs IaaS. The data role runs SQL Server. It's where the data for the SharePoint environment is stored. Not just the documents, but all the metadata and all the information about things like the taxonomy of your site. And then the service application tier can include one of multiple service applications that come out of the box. things like the managed metadata store, other types of service applications. It can also include third-party service applications that you may run. But these are basically some kind of shared service. Search is one example of a service application. It's a shared service that's consumed by these various other tiers itself. Oftentimes when we design environments, we are designing around these three tiers. In other words, we'll have a dedicated set of servers for the web role, a dedicated set of servers for the data role, and a dedicated set of servers for the service application role. Those may not necessarily be physical servers. Oftentimes they are actually virtualized machines, and we'll talk more about how you might be able to do that. Smaller SharePoint designs, we have been involved with them over the years. We generally try to avoid what's called the all-in-one server. This is where you have your database role installed together with everything else on SharePoint. The reason we try to avoid that is for the reasons I mentioned earlier. There's a lot of contention between a database server and a SharePoint server. SQL Server, for example, goes and maps out the amount of memory that's available to the operating system, and it essentially assumes it has full unfettered right to all of that memory. So if you put SharePoint on the same box as a SQL Server, you get issues. We've generally in the past tried to make sure that our clients at least separate off their database role from the rest of the SharePoint roles. This is a minimum requirement for most of our clients just to improve performance even of the smaller environments. Moving up the scale, SharePoint 2010 now allows for a 4-server farm that's fully highly available. It's the smallest farm configuration that you can build that is fully available. In other words, if you lose any one of those servers, you can actually continue to operate on the rest of the servers. It's available at the web tier through network load balancing, which I'll talk a little bit more about how we can set this up both hardware and software. It's available at the SQL tier either through clustering or SQL database mirroring, which I'll talk more about later on in the session. And then it's also set up even at the search tier to be fully available. SharePoint 2007, the smallest farm that you could create that was highly available was actually a 5-server farm. And the reason for that is that the index portion of search needed to run on its own dedicated server to be able to propagate copies of the query out to multiple machines. You could put query and index on the same machine, but then if you tried to provision another query, it wouldn't allow it to propagate that copy of the query out. SharePoint 2010 doesn't have this limitation, which is why you can get away with a 4-server farm as part of kind of a base build of an environment that needs full high availability and disaster tolerance built in. Other types of environments, in fact, the kind that we most often set up, or at least start our clients with, is where you break out the servers off onto their own separate roles. So a 6-server farm, for example, is kind of an ideal best practice farm in that the web server roles are broken off onto their own machine. The service applications sit on their own pair of machines, and then the database server is also on, again, a high availability cluster or high availability mirror. The advantage to doing this is that you separate the very intensive service application traffic from the web traffic itself. So that if you have, for example, an index operation going on or some other type of operation that happens at the service application level, you actually won't be affecting your end users here at the web level as much as you would if they were together on the same machine. Now, of course, you may look at this and say, well, I don't have the budget to buy 6 servers. Again, this is where something like server virtualization can come into play if it's done the right way. From a scalability perspective, SharePoint 2010 is highly scalable. As I mentioned, we're starting to set up environments, personally up to 500,000 users in size, and there are case studies out there of, multi-million user SharePoint environments. The scalability of SharePoint is that you can actually scale both up and out at the different tiers. You can scale out by actually provisioning multiple web servers in this case, or multiple service application servers, so you break off individual service applications. For example, you can put Performance Point on their own dedicated machines or Excel services on their own dedicated machines. It's scalable from the data perspective because you can actually split up your databases into multiple pieces. So you can have your content databases on one SQL server or one SQL cluster. You can have your search databases on another one. You can have service application databases on a third. It allows you to really scale those environments up and out at the same time. And then from a search perspective, Microsoft re-architected the search to allow you to be able to stripe your index partitions across multiple query servers. So you can actually have redundancy of the query component across these multiple index partitions and break up what it is that you're actually indexing to allow you to index more and more documents as the environment gets larger and larger. So from a scalability perspective, you can start from a 2-server farm with the same web application infrastructure and scale that same environment up to a 30-server farm without actually that much difficulty. In fact, as I'll show you with the virtualization example, it's actually quite easy to quickly provision servers directly into a farm itself. Okay, so one thing to know about the search component of SharePoint, something that I think is not necessarily fully understood, is that the fact that there really are 2 search engines for SharePoint 2010. There's the native SharePoint 2010 search, which is the search that's the new evolution of what was in MOS 2007. And then there is what's called a fast search. Fast search was an acquisition that Microsoft made of a Norwegian company that built this search engine for SharePoint. It has additive capabilities above and beyond the capabilities that are built into SharePoint's native search itself. So I've got 2 slides here, just to give you an idea. SharePoint Foundation, of course, is the most limited version of search and what you can do. Once you start getting into SharePoint 2010s and then search servers, you get a lot more capabilities. But then it's once you start, it's only fast search that starts to add on the capabilities above and beyond what's provided within native SharePoint 2010 search. It is a different SKU, so you have to buy it separately. But you may, depending on how you're licensed with Microsoft, sometimes you may already have a license to it. The killer app, by the way, the one that the majority of our clients look at from an additive perspective is the visual preview capabilities. So that's basically the ability to go through thumb through a document when it comes up in search results without actually opening it up. So if you get your multiple documents, you can actually flip through the pages of them. That's one of the things that a lot of clients of ours have been implementing fast search to be able to do. Okay, virtualization. I'm going to throw one caveat out here before I begin this, in that normally the virtualization topic that I do is a whole hour and 15-minute long presentation in and of itself. I'm condensing this portion of this presentation into about 15 minutes, so I'm not going to be able to cover all the detail that I would normally cover. And even when I do cover an hour and 15 minutes long, there's still caveats that apply to virtualizing SharePoint. In other words, be cautious about it, understand ways to improve performance out of your virtualized environment, but understand that it is fully supported to virtualize SharePoint. The only thing is if you virtualize it wrong, you will have performance issues in your SharePoint environment. So a couple of best practices around virtualization and things that you can do to improve the performance of your environment. Number one, I would say the best thing that you can do is to have dedicated hosts for your SharePoint environment. The biggest problem with our clients a lot of times is that the SharePoint team and the virtualization team are different pools of people. The virtualization team set up virtual hosts, and then they host the servers within the organization. So oftentimes the SharePoint people just get thrown in together with a bunch of other Exchange servers or Active Directory domain controllers or some other systems that are virtualized on those same hosts. And the end result is that you end up with a lot of performance issues. Well, if SharePoint 2010, if you have the capability to do this, the best practice is to get yourself a dedicated pool or dedicated cluster of servers that's just for your SharePoint servers, particularly since some of the requirements around the SharePoint servers are actually quite high. I've got a slide here where we'll talk about how much memory and processor you need to allocate to each one of these systems. But needless to say, preferably you have your own dedicated host so that you're not running into any issues with allocations. Don't put any software on the host OS except for antivirus or backup. That may seem obvious, but we've seen a lot of, for example, especially with Hyper-V, people installing things on top of the system itself, which has a licensing implication, by the way. Microsoft doesn't charge you for a virtualization host that only runs virtualization host software. They charge you when you start to run it. For example, if you turn the print server role on a Hyper-V machine, you get charged for a license for that machine. Whereas if you didn't have that on, you just had Hyper-V, you would actually only pay for the individual guests running on that machine itself. Another big thing, don't over-allocate your memory. Memory ballooning can get you into a lot of trouble. Dynamic memory is what Microsoft calls this in Windows Server 2008 R2SP1. And then don't over-allocate your processors. This isn't something that the SharePoint team has come out and said in regards to virtualization, but it's actually something that the Exchange team, when I worked with them to write a white paper for Microsoft, they specifically came out and said, listen, if you're over allocating your processors over a 2-to-1 ratio via the number of allocated virtual CPUs versus the number of cores on that host, we won't support you for that machine. You'll have to move sessions off to another system. The SharePoint team hasn't necessarily come out and said that, but this is the kind of best practice guidance I use, since SharePoint servers virtualized are actually similar in a lot of ways to Exchange servers. What this means, by the way, just to translate that 2-to-1 ratio, if you have a host that has 2 quad-core processors, that's 8 cores total on that machine. You can allocate to individual sessions up to 16 virtual CPUs. So if you take one session, you say this one has 4, this one has 4, this one has 4, this one has 4, that's 16. You're already at a 2-to-1 ratio. For the best performance, by the way, in the fastest running environments, we actually keep that closer to a 1-to-1 ratio. Also, make sure you have the proper amount of disk I/O. The minimum is 0.75 IOPS per gigabyte of your content databases. Preferably, it's actually closer to 2. So the 0.75 is when Microsoft actually just came out and said any lower than that, and we're going to have you go back and have to give more IOPS to your environment. But make sure you're addressing disk itself. Virtualization, especially when you put that the virtual disk layer in there, there's a loss of performance of going from just a standard physical disk to a virtual disk itself. So on that note, if you want the best performance overall out of your disks, you can do what Microsoft calls the pass-through disk, which is to allocate a physical disk directly on the host itself to the individual guests. So you're not actually using a VHD. You're directly allocating that disk to the individual guest itself. That has implications for things like if you want to set up for live migration, Hyper-V live migration, for example. But in any way, you do get the best performance out of a pass-through device. It's also known as a raw device mapping in some third-party software. From a virtual disk perspective, I do recommend you use fixed-size disk instead of dynamically expanding. Hyper-V in particular has been greatly improved in the latest version in the way that it actually does dynamically expanding disks versus the original release of Hyper-V. But that said, there still is a performance loss when you go to dynamically expanding disks, because every time it has to expand, there's a bit of a delay and there's a bit of a loss in speed itself. So consider using fixed-size disks instead of dynamically expanding disks. From a network perspective, aggregate multiple NICs on the same host for the guest network. So oftentimes we'll have a blade server that's running as a virtual host that has 4 gigabit network connections that all get aggregated back. And that the aggregate bandwidth of those 4 connections is what's used for the virtual network cards themselves. And then on the same perspective of the disk, if you also allocate pass-through network cards, you get the best performance overall. Other things to note in terms of which role servers are the best candidates. Traditionally, it's always been the web role. The web role itself is the one that is the easiest to virtualize. The one thing I would caution with that is this also depends on how many application pools you're running. Every application pool that's used for content consumes 800 megabytes minimum per server that it runs on. So if you have 8 application pools running on a server, that can add up really quickly. You have to allocate over 6.5 gigs of additional RAM on that machine alone, above and beyond the minimum requirements for that individual machine. So in some cases, it's not always the best candidate, but it usually is. Service application systems are also generally good candidates, depending on what they're used for. But do be cautious with the database role itself. That's the one that is usually the last one that's virtualized. It can be virtualized, but remember, virtualization just for the sake of virtualization doesn't always make sense. In most designs we do nowadays, the SQL tier itself is still kept on physical servers itself. And in terms of the, I mentioned kind of the matrix that we use with our individual clients. This is a matrix of basically the bare minimum that we'll support as an organization of SharePoint servers versus a recommended level versus what's oftentimes put in place, especially if you have enough resources, more of an ideal level for example, a server that's just running web, so no other service applications, versus one that's running just some individual service applications, or search, which is generally a heavier service application, or if you've combined your web and your search and all your service applications all on the same machine itself. So this gives you an idea of kind of the baseline that we'll start at for some of our clients. Okay, and just to illustrate some of the sample designs, some of the sample virtualization designs that are out there, this is an example of an organization that in the past would probably have taken that single machine that they have and installed SQL Server and installed SharePoint and put everything all in one box. For those clients today, we actually oftentimes recommend that they turn that single box into a virtual host. And then that virtual host itself can have multiple virtual guests running within it. Now, of course, there is some overhead to virtualization, and you may lose somewhere between 2 to 3 to maybe even 5% depending on some variables that are involved. So you do lose a little bit of the capacity of this machine just with the overhead involved with virtualization. However, that said, we found in some of our testing that by separating the SharePoint roles from the database role, even just from a perspective of you're allocating this much memory of the host to this machine and this much memory of the host to another machine, you can actually improve performance because the SQL Server will just use its 12 gigs of RAM over here, and then the SharePoint server will use another 10 gigs of RAM here, and they're in separate space and they're using separate CPU threads. So there's some big advantages to doing something like this, not to mention the fact that you can bring up a test farm within the same environment, you can bring up multiple servers, and you can also take advantage of some virtualization licensing options. Other environments. This is actually an interesting design that's essentially just a 2-server environment that's fully highly available and that it can also take advantage of having test and dev environments in the virtualized space itself. So in this case, you'll see that SQL Server itself is virtualized, and they're actually using SQL database mirroring to have all the databases from the SQL Server mirrored over to the second server. And I'll talk more about mirroring later on in the session. But the advantage to that is that you can actually do this without any shared storage. So these are 2 completely separate virtual hosts that aren't using any type of virtualization failover software. So I'm thinking like your Hyper-V live migration or third-party failover types scenarios. So you don't even need shared storage. This doesn't even require SanDisk, for example. So some of our smaller clients have set up 2 virtual hosts that are relatively low cost with direct storage on it, and they've set up environments like this that are fully highly available, that have test farms and dev farms and a SQL witness server to fail over the databases from the principal server to the mirror, et cetera. So this just gives you an idea of the type of environment that you can set up. By the way, you'll note I said here this only uses 2 Windows Enterprise Edition licenses. I briefly mentioned that, but Microsoft has these virtualization licensing options that allow you to actually, when you purchase an Enterprise Edition of Windows, it gives you up to 4 running guests at a time on the machine that's running that enterprise version of Windows. So it's something to note. In this case, that's just 2 Enterprise Edition licenses of Windows plus your SharePoint licensing, of course. Other environments, and in fact, probably the more common environments we'll run into, these are where you have a mixture of physical and virtual servers. As I mentioned earlier, oftentimes the database servers are on their own physical machines, and the rest of the servers within the farm. In this case, you'll see we've got 2 at the web, we've got 2 at the service application tier, so it actually provides for that best practice 6-server farm. Oftentimes this would be cluster, and then the database is mirrored over to a 3rd server. There's a lot of different options in the way that you can architect this, but fundamentally this is really just 5 different blade servers or 5 different physical servers that have a whole bunch of virtualized SharePoint servers that can handle tens of thousands of users depending on the configuration of those virtual hosts themselves. So it definitely scales up very easily in a virtualized space like this. And then I did mention the really large virtualized SharePoint environments. There are some case studies. For example, one's there's a department of the UK government that fully virtualized a very, very large SharePoint environment. So there's different case studies of ways to do it. But again, you have to have a really good reason for doing it, particularly for those database roles themselves. If it's because it's part of your DR strategy or there's some reason why you need to virtualize everything, it can be done. It's just that you have to properly address disk I/O, you have to properly address your memory, you have to properly address your processor, and you need to watch the performance metrics of those to make it happen. But like I said, it's scalable and it allows you to build up those environments very quickly. I don't have a slide for it because it's relatively recent, but the design that we did recently with 500,000 users, it actually is starting with 50,000 users, but it needs to scale up to 500,000 users. To do that, we just actually built in auto-scaling into the environment. So we're using System Center Operations Manager to gather the performance metrics of servers in a particular tier. In this case, let's say like the web tier. And as the performance of those systems, as it will get consistently above a certain threshold, what will happen is it will automatically use a System Center Virtual Machine Manager to provision a new web server. And that new web server will then just be added into the load balance pool, so you can actually auto-scale the environment up. So in their case, they're actually allowing that environment to scale starting from 50,000 users. As it scales up to 500,000 users, just continue to add servers in to a particular tier itself. And then speaking of the performance metrics, there's of course SharePoint-specific performance metrics, especially if you're using something like Operations Manager, which has management packs that look for those. But there's some really, really simple ones that are just Windows-based ones that you can tell whether or not you're running into performance issues on your environment. So this includes processor. If your processor goes above 60% utilization, you can start to see some slowdown. Anything above 90%, you're going to have some serious issues. Available memory below 10% is going to be going to get you into trouble. Disks, anything when you're having greater than 15 milliseconds of read or write latency, you've got issues. You can use these particular metrics to kind of determine where the performance issue is, whether or not it's on a virtual host perspective or a virtual guest. For example, if I found that my network bandwidth and my network queues were in the red for my individual guests, but on the host itself, everything was fine, I would know that I haven't allocated enough, or I should go through and allocate a pass-through network card, for example, to improve performance on that individual machine. So use these metrics. And by the way, this whole slide deck is available for download on SlideShare. I'll give you the link at the end so you don't have to necessarily furiously scribble all this down. Okay, so that takes me to the demo here. In a nutshell, what I'm doing in this demo is I've created a template server that already has SharePoint installed. I installed Windows Server 2008 R2. I patched it. I got it ready to go. Put Service Pack 1. Put the SharePoint 2010 binaries on it. Install Service Pack 1 for SharePoint 2010. But you stop before you run the configuration wizard. Don't run the configuration wizard. Just get it to the point where the binaries are installed, all the prerequisite steps are done, and that server is ready to be a template. You shut it down. You basically, in this case, I've used Virtual Machine Manager, which scrubs out all the SIDs and then gets it ready to be a template machine. And then basically, you can go set it up to automatically start, automatically kick off a PowerShell script, which will add it into a SharePoint farm. And we have a PowerShell script that we created for the book that I'll give you guys a link to download if you're interested in it. But that is what we use to install, to actually automatically provision an environment. So let's connect to San Francisco. This is my Hyper-V host that I have running back in my home environment. If I'm lucky, my wife won't shut the server off while I'm in the middle of this presentation. It's happened once before. In any case, this is just, I've set up a machine. It's a couple quad-core processors, 32 gigs of RAM. Basically, it's an ideal machine to be a virtual host, which is, also since I have a netbook that I carry around with me, that's not going to be running SharePoint. So the RDP works pretty well for this. In any case, this is Virtual Machine Manager. This is actually Virtual Machine Manager 2008 R2. Virtual Machine Manager 2010 is currently in beta. I plan on actually updating this environment for this, but there's a public beta for that. It's actually got some new whiz-bang features above and beyond what this one has, but I'm actually fairly satisfied with the VMM 2008 R2. So I have a running SQL server as part of this environment. And in fact, this particular demo kind of relies on me having a centralized SQL server. SQL doesn't work well to be templatized. SQL doesn't like to have its name changed after you install it. So SharePoint doesn't care. SharePoint can go through and you can swap out the names and it doesn't make a difference. So in this case, what I'm going to do is I'm going to use this self-service portal site that comes with Virtual Machine Manager. The most common example of where we've seen this portal used is when you have developers in your environment that want to be able to spin up their own SharePoint farms, and you want to be able to kind of automate that process and have them build it off of individual templates. So you can actually give them access to the self-service portal, and they can go through and provision their own SharePoint farms. So in this case, I'm going to use this template machine, and the template machine already specifies that it has 8 gigs of RAM, 300 gigabyte disk. It uses up 1 quota point. You can give each one of your users a certain amount of quota points so they're not overusing an environment, for example. But let's call this TechEd AU. And give it a password. Okay, so I'll create that system. And what that will do is that'll basically start to create a virtual machine. I can check the process of it through the web-based console, or I can actually switch over here and see it's creating the individual sessions. So as you can probably tell, I've done this demo a few times. There's quite a few leftover sessions here. But these are all actually individual farms that all have their databases on this centralized SQL server that I'm running here. So this is going to go through and create that server. This part of the process actually takes about 7 to 8 minutes. If I had a faster machine, it would actually go even quicker. The example I talked about earlier, the auto-scaling environment, as I mentioned, you can actually have System Center Operations Manager kick off or tell VMM to start this process. It's all PowerShell driven, so it can actually kick off a PowerShell to create a machine based off of an individual template. And you can actually go through and update this template on a regular basis. As a side note, of course, let's say, for example, when Service Pack 1 comes out for SharePoint, or as it came out, you would need to update your template to be able to have new servers come out with that Service Pack. Same with any cumulative updates. You need to build a server based off of this. Again, it only takes 7 to 8 minutes or so. Install the latest Service Pack, shut it down, create a new template machine off of it, and you're ready to go. And you can specify all the settings of these individual machines themselves. So I can go through and specify that I have more memory on an individual system, or I have more processors allocated to it. It's all customizable through the template properties themselves. So I'm going to let that run in the background. As I said, that'll take about 7 to 8 minutes, and we'll come back into that here. So let me continue on here. Okay. Data management. This is a key area within SharePoint that oftentimes gets neglected, and a lot of the reasons for that is that in many cases, just like with the virtualization teams, in many cases there's a SQL team composed of DBAs that have SQL servers that they set up and administer, and they know SQL very well. And then there's SharePoint teams that oftentimes know web-based, ASP.NET. They may be developers. They may be branders, or basically there's different sets of people in a lot of cases. So there's not a lot of necessarily DBA experience in SharePoint environments. So you end up with a lot of SharePoint farms that have great hardware, but it's not set up properly. So I've included some of the most common best practices that we've seen that are very easy to implement, that can actually help to improve the performance of an environment. Starting with data distribution. If I had you guys don't have pennies anymore, but if I had a 5 cents for every time I ran into an environment where everything was in just one big content database with one big site collection into it, I'd probably have $2.50 by this point. But I'd have some money. In any case, it happens a lot. We run into environments where, especially since it's really easy to do this, you click next, 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 finish. Oh, you've got SharePoint. Guess what? Everything's in one site collection. Everything is in one content database. And that content database starts to grow very, very, very large. We have clients with terabyte, multi-terabyte content databases. Yes, Microsoft now says you can have up to 4 terabyte size content databases. Do you really want a 4 terabyte content database? Imagine spooling that off of tape or trying to do anything else with that if you needed to recover that database. Not a good idea. The general best practices, it used to be you'd try to keep it around 200 gigabytes in size. The general best practice still kind of applies in that case, even with the feature improvements in Service Pack 1, which, like I said, now Microsoft supports up to 4 terabytes in size, and even larger if you're in a records management space. So if you have the capability to do it, the best thing that you can do from the beginning is to distribute your content across multiple content databases from the get-go, from the start of your project. That, of course, requires you to have multiple site collections. If you only have a single site collection and it's already 800 gigabytes in size, you're really looking at third-party tools at that point to be able to extract content out. Yes, there's ways to do it with STS-ADM. Yes, there's ways to do it with PowerShell, but those are not full fidelity moves. To get full fidelity moves, again, you'd have to look at a third-party space if you need to split up a really large site collection. So what you end up, what in a perfect world, what you would do when you're designing, especially if SharePoint's used as a document management environment, is you would go and define what are the functional business units within your organization, where are the different teams of people that work together, and give them their own site collections and give them their own content databases. That way, the human resources department has its own content database. That way, the IT department has its own. Marketing department has its own. If you can break up your organization into those functional pieces from the beginning, you end up with much smaller content databases right from the start. So instead of that 800 gigabyte or 1 terabyte content database, you have 30 databases which are around 50 gigabytes apiece. Some will be larger, some will be smaller, but it'll be much easier to deal with that data. And you'll have much more options for distributing the data as well. And we'll talk about some of those distribution options. So that's the preferable way to do it. You'll note here I have multiple MySite databases. Since every MySite is a site collection, that's easier. You can split out those MySites across multiple content databases. But splitting it off is the ideal way of doing this. Now, if you're already stuck and you've already put it into one content database, again, you may have to look at the third-party space, or you may be able to use a concept known as remote blob storage, or RBS. You guys have the Royal Bank of Scotland here? No? Yes? Apparently RBS, the Royal Bank of Scotland, actually uses RBS. This is what I'm told. RBS stands for remote blob storage. What it is, just to graphically illustrate my little diagram here, every document and every picture that's stored within SharePoint by default is stored within the SharePoint content database or within a SQL content database as a blob. A blob is basically the unstructured content within that database. Somewhere around 80 to 90% of the average SharePoint content database is composed of blobs. The rest of the data is the metadata, which itself is structured data. SQL does very, very well with structured data. It's meant to handle structured data. It's not necessarily the best location for unstructured data. So RBS, what it does is it allows you to take those blobs, put them on an alternative storage location, and actually have your content databases only have the metadata and the other structured content. And actually, you can actually put this on, let's say, faster spools of disk, whereas this may be on some different type of disk, or this may be on cheaper disk. So you're taking your faster disk, and you're taking and you're basically reducing the sizes of your database by using something like RBS. Now, caution I'll put out there is that you have a lot more to think about when you're using RBS. You've got to back up both of these locations at the same time. So you've got to be backing up your blobs and your content DB. You've got a different administration point to deal with. You have to deal with the uptime of this particular environment plus this particular environment. So there's some complexity with enabling RBS. But in very targeted use scenarios, we found that it's a very useful tool for reducing those massive content databases in size and being able to tier the content onto different systems. That said, the vast majority of clients we have that use RBS will use a third party. And I highly recommend, if you're interested in RBS, to go to the third-party space. Microsoft has what's called the file stream provider. We talk about turning that on in the book itself. However, it's more of kind of a demonstration feature in just this is how you actually set up RBS itself. In my experience, it's best to work with the third-party provider that integrates together directly with the RBS API if you're interested in using that. Okay, database optimization. This is a really easy thing that you can do to improve the performance from a disk I/O perspective of your SharePoint content environment. Basically, you take your content databases and break them up into multiple files. Not multiple file groups, but actually physically multiple files. There's two different concepts in SQL. You can break up things into different file groups, so some tables are here and some tables are here. That's not what I'm talking about. I'm talking about physically taking that MDF file and breaking it into an MDF file plus multiple associated NDF files, which then you can move to different volumes. So you can actually have your database A broken into 4 pieces in this example. You'll see I'm breaking it up into 4 different pieces. Database B is also broken into 4 different pieces, and my tempdb file broken into 4 different pieces. Tempdb is one of the most critical databases in your SQL environment. It's used for every single transaction that goes in and out of SharePoint. If you do not address the performance of your tempdb file, you could have the best SAN infrastructure and the best database servers with 128 gigs of RAM and all this stuff on it, and suddenly your performance will be really, really bad because your tempdb file, you forgot and you put it on the C drive and it's sitting there and it's trying to use those little RAID spindles running on the C drive of that SQL server. It's not going, you're going to lose a lot of performance if you don't address the performance of your tempdb, which in this case, one of the easy things you can do is break the tempdb file into multiple pieces. I have 4 pieces here illustrated in this particular example. 4 because this is running on a SQL server that's a 4-way server, 4 processors. You may see it listed that it's actually per core that you do this. Strangely enough, the per core guidance actually comes from the SQL 2000 days. That's stuff that's been regurgitated over the time in SQL 2005, 2008. If you go and you actually look at the performance metrics, it's actually, for example, if these were 4 6-core systems, you would not break your database files into 24 different pieces. You don't get better performance doing it that way. In fact, from the tempdb perspective, there can actually be a degradation in performance. So what we found in our testing is the best case scenario is that you have it broken out by the number of physical sockets on the individual SQL servers. So if there's 4 physical processors that have each multiple cores, you'd break it into 4 pieces. If there's 2, you break it into 2 pieces. How does that affect a virtualized SQL server? Generally, I'd say you do it half the number of virtual CPUs on the machine. So if you've allocated 4 virtual CPUs, you break it into 2 pieces. There's no one specific number. It all depends on a lot of factors in terms of your disk I/O. Normally, I would say work directly with your SAN vendor to figure out how to break this up. They have some experience doing this. But if you're managing your own environment, and if you're running into problems where there's a lot of contention on individual databases, very simple thing to do, break it into multiple pieces, split it out between multiple volumes, and you'll get better performance overall. At the same time, I would also recommend taking those individual database files and pre-sizing them. The reason for that is that one major factor of SharePoint lockups is auto growth in databases. When the databases have to grow, they actually end up putting a lock on that individual database file while it's grown. It grows fairly quickly, but there can be a noticeable effect. You get pages that start to time out. You get slowness overall within the site itself. So to avoid that, one of the things you can do is just pre-size your content databases. And the other advantage of pre-sizing your content databases is that you don't get the disk fragmentation that you would get if you had multiple database files on the same server that are all auto-growing at the same time and fragmenting themselves across that disk. So let's say you were planning for a content database of 100 gigs in size, and you want to break it into those 4 chunks. That's 4 chunks of 25 gigs apiece, each running in a contiguous space on that individual volume. Same thing with the tempdb file. There's specific guidance around that is that you want the tempdb file to be approximately, here it is, 20% of the size of your largest content database within reason. If you have a terabyte content database, don't create a 200 gigabyte tempdb file. I'd say you're generally maxing out at maybe 70, 80 gigs in terms of what you would create a tempdb file as. But that's something to note is that again, 20% of the size of your largest content database, pre-size your tempdb file. People don't realize this, and I mentioned the performance implications of tempdb, but the default size for the tempdb file is 8 megs. Well, when you reboot that server, no matter how big the tempdb file has grown to, it'll actually default down to the default size. So what ends up happening is that then it has to auto-grow again. And so you can end up with the effect of rebooting a SQL server and having slower performance as tempdb has to auto-grow. Because since tempdb is used for every transaction, every lock that's created when it's auto-growing is going to have an issue. So definitely pre-size it. And by the way, note, if you are pre-sizing your SharePoint content databases, Microsoft has included very nice little health monitor that will go through and say, hey, guess what? You have a lot of white space within your database. Would you like to fix this? I recommend turning that off. It's a little too easy to click the button and say yes, and suddenly all that work that you did is now lost because it will very quickly take off all that white space and drop the size of that database. But also one thing to note, if you are using SQL transparent data encryption, the tempdb instance itself is encrypted. Okay, I'm going to jump back into that demo here, and then we'll jump into high availability. So let's see the system. It's set up. It says stopped. Let's actually start that up. Okay, we'll start this machine up, and then what I'm going to do is log into it and kick off the PowerShell script, which will automatically join the server into the farm itself. Or, sorry, create a new farm in this case. So let's connect to this machine. And it should come up pretty quickly, and we'll be able to log in and kick off that PowerShell script. This is part of the process that can also be, again, fully automated if you need to. I wouldn't necessarily even have to go through this part of the process itself. You'll note, by the way, that the template itself, the template that I created, automatically joined it into the domain. It's a member of my companyabc.com domain. I just gave it some credentials of a system that has the ability to add it into the domain itself. So let's log into this server. And by the way, there's another System Center tool called System Center, what's called Apollos right now, but it's going to be called System Center Orchestrator in the 2010 time frame. And let's see, my button should come up here in a second. It's refreshing the page. It allows you for automating workflows across multiple products like System Center Virtual Machine Manager or yeah. Now I locked myself out. There we go. You know, take for granted the fact that it's going across a massive ocean, 10,000 kilometers, but I shouldn't have done it to full screen. Let's try this. Okay, come on. There we go. I'm going to take that off full screen. That's just throwing me off. Okay, let me log in here. Of course, never use your domain admin account for something like this unless you're doing a demo. You guys all know that, right? I've actually got a slide coming up that talks about which service accounts are the best practice ones to set up. Okay, so this is, again, the TechEd Australia 2011 server. It's set up. It already has SharePoint running on it. You'll note I could go through and run the configuration wizard right now. But I'm actually going to run this PowerShell script that we created for the book that will allow me to start a new farm. So I'm not going to join an existing farm. I'm going to create a new farm. I'm going to point it to SQL 10, my SQL server. I'm going to give it TechEd. Put in some credentials. Enter passphrase, all variables. Enter default port. I'm going to use NT-Landman just for this demo because I don't have the time to create the SPNs, but normally I would say definitely use Kerberos for this kind of thing. And then what this does is this takes those variables and automatically goes through and creates you a SharePoint farm with the name, with this particular name as part of it. It creates databases which don't have the GUIDs as part of their name. In fact, actually, we use PowerShell for the creation of pretty much any new SharePoint environment that we set up because you can go do things like specify the names of the databases themselves. So let me actually show you on that SQL server. It should create that config database pretty quickly. But you'll note all of the different databases I have running on this machine. And let's see, the TechEd one should come up here pretty quickly. Still have the Middle East one. There it is. Oh, yeah, it was there. So you'll note, again, it has what the nice things that our scripts do is that it just takes the name of the farm, puts an underscore, and the type of the database that it has. It does that for every database. There's two scripts, actually. There's one that's a simple one that just creates a farm, and there's the other one that goes through and configures each one of those service applications themselves. So again, I'll give you the link to this that individual script towards the end of this presentation. So that's going to be running in the background. Let's let that run. And I'll come back one last time just to show you that it's done. But again, you see that the concept, okay, here we go, it's running. The concept is quick and easy provisioning and scaling of your SharePoint environment. Okay, high availability. At the data tier, when it comes to the question between clustering and mirroring, I'll grant you that it does depend on what you're familiar with. If you're familiar with dealing with a cluster, oftentimes you'll put a cluster into place. But if I end up having two different SQL servers, and I have to make the decision between clustering and mirroring, oftentimes I actually will choose mirroring over clustering because it has the distinct advantage of allowing me to basically have a constant backup of my SharePoint environment. I'm creating a second copy of my databases on a different machine, whereas with clustering, it's shared storage. If I lose that storage, I lose all my databases. So there's some distinct advantages to mirroring over clustering. However, there's a couple advantages of clustering. Clustering generally fails over more quickly, and it's also supported for all of the databases, whereas mirroring doesn't support all of the databases, and I'll talk about which ones you can do. Mirroring itself, it's basically a continuation of the log shipping concept, which came out with SQL 2000. And it's improvement on that. It came out with SQL 2005 Service Pack 1. There's been some major improvements made in the 2008 time space. So SQL 2008 or 2008 R2 has some big improvements to mirroring. But you can actually mirror in both the enterprise and the standard editions of SQL Server themselves. So you don't necessarily have to buy the most expensive version of SQL Server to be able to do mirroring. However, there's some differences in the types of mirroring you can support between the two different versions. Then the big key in SharePoint 2010 is that SharePoint 2010 is now mirroring aware. You can specify all of your databases that have a mirror location. So you can go say, all right, this is the location of my mirror database, and that allows SharePoint to automatically be able to fail over between the principal server and the mirror server for your databases. With SharePoint 2007, you had to create a SQL alias to be able to do that kind of thing. There are three different models of SQL database mirroring which we've oftentimes seen and used. The first model is the model where everything's all within a single data center. In this case, you actually have all of your databases, or the majority of your databases, and I'll talk about there's a few which aren't supported, and you have them synchronously mirrored over to another SQL server. This may be that model I talked about earlier where there was the two virtualized hosts and each one was set up for mirroring. That model would apply in this case. Basically, you have some very good bandwidth, you have very good connectivity between these two servers, and you're mirroring all of these databases from the principal server over to the mirrored server itself. The reason why I say synchronous is that synchronous is the only type of mirroring that's supported by the vast majority of these databases. There's another kind of mirroring called asynchronous, which is only supported for the content databases and the secure store database. And that's the type of mirroring that's actually provided with with the enterprise edition of SQL Server. The reason why asynchronous is only supported in the enterprise edition is it's really fundamentally the only one that you can use over a WAN that has anything greater than 10 milliseconds of latency of spikes. So basically, you want to average closer to 1 millisecond of latency and a gigabit of bandwidth. So if you don't have the bandwidth, you have to use asynchronous mirroring, which is only available in the Enterprise Edition. Synchronous uses a dual-phase commit process to basically wait for the data to be written into both sides before the transaction is committed. The downside to that is if there's any type of failure to the network connection or any type of slowdown in the network connection, you can have transactions time out, which is why you need to use asynchronous mirroring if you're doing something across a slower network connection. The second model is still a synchronous model, but it's a model where you actually have a cross-site farm where you have, let's say, one location which might be in the CBD of a city, and then another one that's a few kilometers away in some kind of backup data center. So you've got some kind of site failover, but it has to be relatively close because you need pretty high latency. Again, a millisecond latency spikes up to 10 in some cases, but you need really good latency and really good bandwidth to be able to support a situation like this. Microsoft has a really well-written case study for SharePoint 2007, but a lot of the same stuff still applies for SharePoint 2010, and that case study covers this particular scenario itself. I'll give you the link to that on one of the last slides here. And then the final design, the final model is one where you actually have asynchronous database mirroring of the content databases alone from one location to another, and then you've got a failover farm that's identically configured to the first farm that's ready to be able to either view these databases in read-only mode, which would be useful in a short-term failover scenario, or to be able to do full read-write of these databases. Now, since there's a lot at the service application tier that you'd have to recreate, there's a lot of work involved in something like this. But this is a scenario that you could do with SQL, just using the out-of-the-box SQL database mirroring. In this case, though, asynchronous, which means you need to use the Enterprise Edition of SQL Server itself. In terms of which databases are supported for which versions of mirroring, basically all the databases are supported with synchronous, except for a few of the ones that are actually very easily recreated. Things like the usage and health data collection database, you could very easily recreate that. The application registry service is only used if you're doing an upgrade from 2007's BDC. That's not supported for some reason for synchronous mirroring. And then the UPS stuff, which my guess is it's not supported just because it's so difficult to configure. If you've ever tried to set up UPS, my guess is you're going to a blog site that's Purple Blog, Spencer Harbor's blog. If you've ever tried to do it, he's got the best guidance on actually setting up UPS. And by the way, that's harbar.net is his blog. If you are going through the pain and suffering of UPS, that's a good location for that. In any case, UPS can't, the databases for UPS can't be failed over using any type of mirroring itself. You have to actually recreate those, or you have to actually go through, there's a process, Microsoft talks about it on TechEd, of actually mirroring the profile information from one UPS configuration to another. So aside from that, the rest of them are supported with synchronous mirroring, so there's some advantages to doing that if you're setting it up for synchronous mirroring itself. Okay, other data tier disaster recovery concepts. If you are using a cluster, let's say you have two SQL nodes, why not actually use both of the nodes at the same time in your standard operating situation? So in a situation where you're not having any type of failover. One very easy way of doing that, simply create two instances across those two different SQL machines and have them set up to cluster. One of them is active, so this node is active for the content databases, and this node is active for the service application databases. So you can split up your databases, you can use the capacities of both of those SQL servers, and you can set them up for best practice active-passive for those individual instances. If any one of these servers goes down, the other one can be active for both sides. So it doesn't matter. You can actually fail them back and forth. So there's some distinct advantages of doing it this way. A lot of clients that we have that have two SQL servers set up in a cluster, we'll just set them up this way, and they get the added performance advantage of having their service application databases separate from their content databases. By the way, out of the 15-odd databases, depending on your environment, that you get out of the box within SharePoint, every single one of them has different disk I/O requirements and has different requirements around the way that you set up the spindles and things like this. I'm not going into detail on all of that. There's some good sessions I've seen that actually break down every single database. But bear in mind, a content database works in a very different way than a search database does, and works in a very different way than a managed metadata store database does. So oftentimes you do have them on separate sets of spindles or separate SAN volumes for best performance. Okay, network load balancing. Yes, there is software-based network load balancing. That said, hardware-based load balancers, especially in large enterprise environments, are generally speaking what we run into and what is preferred for a SharePoint environment, as long as you're making sure that you do session-based affinity, which is sticky sessions. You're not trying to switch the traffic back and forth so that the same user's connections goes to different servers. That generally doesn't work well within SharePoint. But hardware-based is the preference. We'll oftentimes deploy these large environments on F5s. There's some big advantages to doing that as well. You can set up some type of global load balancing with different global load balancing modules that are provided by those vendors. Now, if you don't have hardware-based load balancers, software-based Windows network load balancing is fully supported. However, there's some big gotchas that I've seen trip up a lot of people. Number one, software-based load balancing is a layer 2 technology. So a lot of layer 3 switches, by default, if you don't do anything, if you don't set it up properly, it won't work on a layer 3 switch. A layer 3 switch is intelligent to only send the packet to the individual port where it thinks it needs to go to. Whereas Windows network load balancing relies on all of the members of the load balanced cluster receiving all of the packets at the same time. So to get this to work properly on a layer 3 switch, you need to create a layer 2 VLAN within your layer 3 switch, and then put, let's say, in this case, I've got 4 web servers that are all load balanced within that. So it's possible to do that, but that trips up a lot of network people who don't understand how to set up Windows Network load balancing. The other thing to bear in mind is there's 2 different types of software-based load balancing. There's unicast and there's multicast. Unicast itself requires 2 network cards at a minimum, one for the communications between the nodes. It shares the MAC address with unicast, so it can't actually communicate to another server with the same MAC address unless you have another network card. So unicast, you do that. Multicast requires special router configuration. So it requires you to actually have routers that support multicast. There's special, you've got to go in and set up special routes on your routers. So multicast can be a challenge to configure. You have to get your network people involved to do that as well. The last thing I'll note as well, too, is that if you're virtualizing servers that are actually using Windows Network load balancing, there's a known bug, in particular on VMware, where you have to change the way that the network load balancing RARP works in VMware. And if you go up to tinyurl.com/VMware NLB fix, that actually takes you to the VMware article that talks about how to actually set that up. But that's a known bug that many, many times gets our clients that have virtualized SharePoint environments that want to set up software-based network load balancing within those servers. Incidentally, as a side note, yes, of course, this is tech ed. I should note Microsoft does support third-party virtualized environments. I didn't mention that during the session, but it is supported per what they call the Server Virtualization Validation Program. That's KB Article 897615. I've memorized this because it actually used to be the one that specified that Microsoft didn't support third-party virtualization. So in any case, it is supported within the guidelines of that program. So especially being that we're from the Bay Area, we do run into a lot of VMware. That said, of course, we have a lot of large Hyper-V environments. We do recommend Hyper-V. It's a great product. But we do have clients that use Zen Server. We do have clients that use VMware on virtualized environments. And so they'll run into particular things like this, this particular fix that has to be run. So real briefly, too, just to kind of show you a quick slide about, kind of a sample software network load balanced environment. This is just giving you an idea. We've got a couple web role servers that have some IP addresses, and then we have an NLB cluster. We have a IP address that's specific to SharePoint Central Admin. Best practice is have SharePoint Central Admin in multiple servers, have it dedicated usually I use 443 because I want to use SSL, so I have a dedicated port just for that. And then I have it addressed, something like spca.companyabc.com takes me straight to SharePoint Central Admin. You can set it up that way. It's not actually that difficult to do. One for the SMTP virtual server, and then other ones for your different web applications that you have set up. Okay, the scripted installation options, as I showed you during the demo, very useful to script the installation of SharePoint, not just from the perspective that you can name your databases standard names, but also from the perspective that you can actually go through and take that script and use it almost like a build guide. You can take that script and use it to build your environment all over again. You can build a dev environment based on the same parameters that you built your main SharePoint environment. So the vast majority of environments, as I mentioned, that we set up nowadays are all done through PowerShell scripting. Now, I'm not expecting you to read this unless you have really good glasses, but this is kind of an example of our script. If you go to this particular link, tinyurl.com/spfarm-config, it will take you to a good friend of mine's blog. His name's Tony Francole. He's a SharePoint MVP out of Croatia who helped me write some of the scripts for the SharePoint Unleashed book. So he's got them up on his blog. You can use those as a base to start with. They're freely downloadable. They're also available on the SAMS Publishing website because they're in the book as well. Okay. There are some service applications. I know someone was trying to take a picture and just missed it. You want to try again? Again, you can download this from SlideShare. Okay, a few service applications we're still manually configuring just because there's some issues in setting them up. Of course, as I mentioned, UPS is one of the main culprits here. A bit difficult to configure. Web analytics, there's some manual configuration steps that are involved, and some of the performance point pieces. This actually may change because some of it had to do with bugs in the original RTM. I think that's been worked out in SP1, but we need to kind of feel that out. But in any case, we generally do automate most of it, but there's still a little bit of manual configuration in most farms that we set up. Okay. I'm going to quickly go through security because I want to just show you guys the end of that demo here. There's a lot to cover in terms of security. There's different layers to security. Most organizations may only be addressing one layer and may only be addressing some pieces of those layers. So there's a lot to consider. There's your infrastructure security around actually the physical security of the environment, making sure you have multiple service accounts, setting up your SharePoint environment to use Kerberos, which is a major best practice, which I highly recommend. Data security, role-based access control, I'll talk about this. Transport security, security in between across the network. You know, you may trust your network guy, but do you really trust him enough that he can plug into a port and be able to read a confidential document that's going between your machine and the SharePoint server? Because it's not, it's in clear text unless you're using SSL. And then edge-based security and rights management as well. I'll talk about each one of these real briefly here. But from an infrastructure security perspective, this is just a sample of the typical list of service accounts that we start with in our average SharePoint 2010 install, and the special rights required for each one of those service accounts. Again, download the slide deck. You can go into more detail and use these as an example, but this is just kind of a basic guideline to get you around that. Kerberos. I don't have time to go into detail to talk about all the ways that you would set this up, but long and short of it is that don't be afraid of Kerberos. Use Kerberos instead of NT-LANman. NT-LANman is an NT-level technology. It's a circa 1996 technology. Kerberos has been around in its Microsoft implementation since Windows 2000. It actually was developed at MIT, so it's not even Microsoft-based. But it is a shared secret approach, which means that the password itself is not sent across the wire. It's basically a secret that both sides know about that's used to determine what the password is. So you can't actually take the hash like you can with NT-LANman and brute force attack it. So definitely configure your sites for Kerberos. Role-based access control. This is the concept of being able to give someone rights to an area within SharePoint based on their role. When it's set up in a perfect scenario, you actually have it set up where a new person starts. Let's say they're the marketing person. You drop them into an Active Directory group called marketing, and that automatically gives them rights to everywhere within SharePoint that they need rights to. So you don't need to manually go through and configure permissions. You can also use things like Forefront Identity Manager, which allows you to automatically request access into a group, add someone into a group, an AD, and have them be able to gain rights. That large organization I talked about, the 500,000 users, they're talking about 500,000 authenticated users. It's not an anonymous access scenario, and they're all using AD, they're using Forefront Identity Manager and role-based access control methods to gain access into SharePoint. Transparent data encryption. If you're really interested in this, I'm actually going to do a session on this tomorrow. This is a really slick concept where you take and encrypt your content databases at the database level. So SharePoint's not aware of the encryption itself. The encryption happens within SQL itself. Relatively easy to set up, fully supported within SQL Enterprise Edition, but it's a way of basically going through a set of keys to encrypt your databases so that when you have your backup tapes, if those are stolen, nobody can, if they don't have the key, they can't actually access that data. The antivirus. Long and short of it, use a SharePoint antivirus. Microsoft's implementation is Forefront Protection for SharePoint. We've been using that a lot. This is the old Antigen product. It uses 5 antivirus engines at the same time. They're all running at the same time. So we've had a lot of success using that. If not that, there's a lot of third-party antivirus products that are out there. I definitely would recommend it for SharePoint. Transport security, use SSL when at all possible, even internally, as I mentioned. Use IPsec if you're in a very high secure scenario, and that would be between the different servers. Between a web server and a database server, there's no encryption going on there. So if someone were able to monitor that traffic, they could also be able to tell what's going on within the SharePoint environment. And then from an edge security perspective, consider an SSL VPN like Forefront UAG, which allows you to be able to have a portal-based page that they go into. Once they've authenticated, they can gain access to not just SharePoint, but Exchange without re-authenticating, access to file servers, OWA, a lot of advantages using something like UAG. And then the last bit of it is rights management services, which is fully supported in a SharePoint environment. This is the ability to control what happens to documents after they've been accessed. So You can set permissions on a file, but once someone opens it up, they can copy it off and send it off to their buddy. With RMS, you can actually restrict copy and paste. You can restrict print. It slows down information thieves from being able to take documents out, and it's something that's fully integrated within SharePoint 2010. So let me go back real quickly just to show you this. This should have completed. And OK, I'm not going to provision a web application. I'm not going to provision any service applications. Let's just go and start up SharePoint Central Admin just to show you our brand new SharePoint farm that was created. And then I'll give you the set of links. Here's that other PowerShell script, by the way. So here's the one that goes through and configures the service applications. So let me pull up. Should be opening really quickly. I think it's opening in the background here. We'll give it a second to open up. Open it twice. Why not? It takes a while for the application pool to warm up, maybe about 30 seconds or so. Does someone have a, well, it's still warming up. Question?
What's your view in this tool called
AutoSP installer? A similar concept to our SharePoint scripts. A little bit more, it goes into, gives you more options and things. You know, ours are fairly basic, but you can use either that or you can use ours to kind of automatically provision SharePoint environments. I don't really care, honestly. It's kind of neat to see your scripts in use later on. You know, we wrote this backup script for the SharePoint 2003 Unleashed thing that used STS-ADM and enumerated all the sites and would back up site collections. And I've seen that in use as kind of scarily as like the main backup for a lot of organizations. But yeah, I mean, I don't have a preference one way or another. Okay, so this is still coming up. Let's let it come up here. Another question? Yes, front row.
In terms of having so much information in so much different segments, how many roles do you think, from an architectural point of view, would be applicable to SharePoint?
Most environments, there's going to be, here, let me enter the credentials here. You've got your SQL DBA type of role, right? Sorry. Okay. SQL DBA type of role, generally, which sometimes is unique. You've got the site collection administrators, which are more of a front-end type of role, and then you've got the SharePoint administrators that deal through SharePoint Central Admin and PowerShell. Oftentimes, there's 3 different sets of people. Site collections admins, maybe hundreds of people within an organization. But it does depend. Some smaller environments, it'll only be a small subset of the users themselves. So, yes, right there.
SharePoint, when you say you're encrypting the database, what's the performance impact?
The performance overhead on TDE is approximately, I think it's around 10% or so, but it's at the SQL tier. It's SQL that's using, SharePoint doesn't do anything else. I'll get rid of the annoying thing. So there,
What size keys being used?
it depends, you can actually specify a different size depending on your encryption requirements, but you can do 128, what have you. So yeah, depending on the encryption, it will vary. Your mileage may vary. If it's really heavily encrypted, it will be bigger. Okay, so that's the SharePoint Central Admin side. You get the concept. Let me take you back to this slide for the more information. And I have to give this away. By the way, so I'm going to, in the 1 minute I have left, I'm going to take the rest of the questions up here, and then maybe about 10 minutes of questions, and then I'm going to go down to the Quest booth, where, as I mentioned, they're going to be giving away 39 copies of this book. As I understand it, once you come up to the book, they'll give you a piece of paper with a number on it, 1 through 39. After 39, I apologize, but there's too many people in the room for a free book. But this is a $60 book, and it's one of the first time, kudos to Quest for going out and buying a bunch of these, but it's one of the first times we've done a mass giveaway of these things like this. So I'll go down there afterwards and start signing the books and giving them away. In the meantime, if you've got that, if you don't have that, go to SlideShare. By the way, please do fill out the evaluation forms. I read all of this information. I use it to improve the stuff. And contact me. My Twitter address is Michael T. Knoll. And I mentioned the book giveaway. I'm going to give away the free SharePoint's conference thing. I guess those guys don't want it. If you can tell me if you caught what the KB article was, the virtualization. There's got to be someone that wrote it down. What was that? No? Did anybody get it? I'm sorry? You're really close, but not quite. Okay, I'm gonna have to come up with a different one.
17615.
Yes, congratulations. Okay, congratulations.